My name is Andrea, and I'm very excited to be here talking with all of you. Okay, well, before I start talking, how many of you are actually thinking, what the heck does Holoclara even mean, and what is this lady going to tell me about worms? Right? I usually never start talks talking about the name of our company, but I thought actually today that I might. Holoclara actually comes from this word holoclaros, which means to complete. And I want to invite you to think about what you need to complete your human experience. And I'm not talking about this season's Louis Vuitton bag, although I wouldn't turn that down. I'm talking about in your more quiet moments, like when you're by yourself or when you're with your loved ones. Has there ever been something that's held you back from really enjoying a simple moment just because someone, either yourself or a loved one, is in pain or disability? And just to paint that picture, let's envision you wake up in the morning and you think, I want to have a perfect flaky chocolate croissant with a fresh squeezed orange juice and a perfect shot of espresso, and I want to listen to my favorite song and not have any worries, right? For some of you, that might be Taylor Swift's new album. Any millennials? Joshua Tree, you too? Come on. You know, for me, it might be Mozart, Marriage of Figaro. I don't know how many of you know that. Duettino, one of the most beautiful songs you'll ever hear, of two voices soaring in the air. Now imagine not being able to enjoy that moment because either you have to think, oh my gosh, I need to find a bathroom after this. Oh, I have to work. I actually need to figure out excuses to tell my coworkers because I don't want them to know that I have a disability because they may actually think that I'm weak. Or maybe you cannot enjoy that moment because a loved one is suffering near you and they have bed sores, they're bedridden, they're being turned in a way where, you know, parts of their body that no one ever really wants to share with someone else is now visible to a stranger. So those are the types of moments that I'm talking about, that it is my mission to try to complete that experience by trying to find things out there that can complete our human biology. And that's what our mission is at Holoclara. So here's a picture of Earth. Look at how beautiful it is, majestic Earth. When I think about this image, I think about what makes it so beautiful, and to me, it's probably nature and people are what make it beautiful. And I hope that by the end of this talk, I'll inspire you to wonder about what are the nooks and crannies of this planet that we can find new medicine for people, and that in exchange, maybe we'll take good care of the Earth. And so of all of the people that live on this planet, millions are actually still suffering despite modern advancements. Does anyone know this artist? Say it out if you know it. Paul Klee. He actually died a very long time ago and had scleroderma, and in his later years drew this painting to demonstrate how he felt like his body was falling apart. He died a very long time ago, and yet we still do not have a cure for scleroderma. We have such incredible modern advancements, like a ring that'll tell you how you're sleeping. We have AI that'll tell you if you have a tumor in your lungs. Now we have targeted, ultrasound to dissolve that tumor. I mean, there's all of these incredible technologies. Genetic disorders, where now the hope of CRISPR can help that. But what about chronic inflammatory disorders? We still don't really have a great cure for that. And in order to really find something, we need something new. I'm not talking about iterating an existing drug to get a piece of the market. I'm talking about something completely new. And if we really study the history of breakthroughs, you'll see that actually a lot of them came from nature, including CRISPR came from bacteria. Did you know that? If you ever watch the Netflix documentary, you'll see that actually yogurt scientists were involved in this discovery while they were studying yogurt bacteria. These technologies, penicillin, statins, all of these came from nature and have helped millions of people. Botox has helped millions of faces, right? Ivermectin, Taxol, Ozempic. Did you know that actually came originally from the secretions of a Gila monster saliva, right? And so these are the places where I'm talking about opening up a whole new class of drugs. And where would we find yet another place that we can look for new medicine? Well, here's a clue. A big clue I'll tell you is tiny creatures, and today I'll talk to you about how worms can inspire the next generation of med tech. Why worms? Well, you know what? To be honest, I don't actually really know. All I know is that there's a lot of proven science. There are really reputable institutes and really reputable journals that are publishing that worms, for some reason, can improve lifespan, fertility, metabolic health, inflammation, obese mouse, non-obese mouse, fetal stubs, turning on. It's really incredible what they can do. So the question is, the million-dollar question is, well, what are they doing? How are they doing it? And before I got my medical degree, I actually got my PhD at Caltech decoding the language of worms. And there, with many brilliant scientists, we together characterized the first Rosetta Stone of the worm language. And so people always ask me, well, how do you get from there to medicine? Like, what's your secret sauce? I'm like, you know what? I'm going to create a slide today on the secret sauce. A simple way to describe it is, once you know what those worms are saying in molecules, you can actually put them into one capsule, let's just say, and then you can separate out that language, and you test them individually, you give it to sick mice, and you see which one makes it better, right? So then from there, you go from the quiet observation of a laboratory into the hustle and bustle of a startup and a company surrounded by incredibly brilliant people that are chemists, patent experts, pharmacologists, regulatory agents, and clinicians that help take nature's innovations into tomorrow's medicine. So I'm very excited to share that our first worm molecule actually went to trial this year. And we successfully completed our first clinical trial, which, by the way, for any MD, PhD, it is our dream to go from benchtop to bedside. So any guesses where this trial was done? Quiet audience today. Come on, someone yell out a country. Australia, yes. Go Australia. Did you know that you guys are actually global leaders in clinical development? I mean, it was really remarkable. We had 56 Australians enroll in our trial and take this medicine. And with incredible safety, we can now turn curiosity into care. And from here, we will now work towards going to patients, figuring out how we can help all of these people suffering from asthma, right? There's some of you out there that carry an EpiPen, right? Do you guys know what that is? It's kind of like, didn't Uma Thurman have that in Pulp Fiction? It's like literally a vial of adrenaline being stabbed into you if you can't breathe. And then people with inflammatory bowel disease, which actually that's the story that I shared with you earlier about someone that can't really enjoy that croissant. And then eosinophilic esophagitis, which doesn't just affect adults, but it also affects children that can't swallow food. They can't eat food, they cannot swallow food. And so, we're really excited to move towards these patients and ultimately serve them so that they can live more complete lives. Okay, enough about us. Who wants to hear some cool science? All right, that was a trick question because I'm still going to talk about us. But I'll just start by saying we know that there's other cool worms out there, right? Like I showed you all of these incredible journals, metabolic health, longevity, fertility. How do we go after them, right? So there's always been this question in my mind, all right, like our first molecule's up and running, it's in clinic, it's doing great, but there's other molecules from worms and I want to get them, so how do we get them? Well, we do what we also did, and I showed you, we divide up the language and we test them individually to see which one works. But are there other cool ways to get them? And I'm going to tell you a story, actually, because, well, that's how I stumbled upon this technology, so I thought maybe I'll just share with you how I discovered it. I was walking into Caltech professor's office, And he's a brilliant synthetic chemist. It was actually with his help that we were able to make a kilo of our first worm crystal. He's running late. It's like 5-10 minutes late. No big deal. And he goes, "Oh my gosh, Andrea, I'm so sorry I'm late. Something crazy happened today." I'm like, What? Tell me." He goes, "We uploaded a paper and it went viral." And I'm like, okay, first of all, that is the ultimate badass move, is when you're a professor and you no longer care about getting into a public, like a peer-reviewed journal, and you're just uploading your data. And he said, "Well, yeah, it's just remarkable." I'm like, "What? Tell me what was the paper about? I want to know." He says, "Well, Andrea, did you know that actually in analytical chemistry, there has not been a revolution in the last century? I mean, more or less, we have improved mass spec and chromatography and NMR, but we still use this." I'm like, come to think of it, when I go into these labs, this stuff does look monolithic. And he says, "Well, and that, people won the Nobel Prize in structural biology by using cryo-EM to elucidate these proteins. No one's ever thought to try to use them in small molecules," which, by the way, the worm language, small molecules. And he said, "Until now." I'm like, "Okay, it was you, right?" And he says, "Yes, it was, but also with a colleague of mine at Caltech." And here is actually his reflection. You can see that this is him sitting in front of the Talos Arctica, which is a multi-million-dollar machine. Costs about actually $500,000 a year just to maintain. And it can shoot lasers faster than the speed of light at a sample and determine atomic resolution instantly. So this is not their paper because, like I said, they just uploaded it to the internet, but everyone wrote about it. This is a Nature review where they talk about how these Caltech scientists prove cryo-EM can elucidate structures in atomic resolution in minutes. Here's an actual quote from the paper. People are smacking their heads, saying, "Why didn't we do this earlier?" So my first thought is, can you put worms under the laser, right? Can we do cryo-EM on worms? And the answer was, I don't know. No one's ever tried, which is my favorite response, because my next question is, can we get a discount? And that's exactly what we're doing now. And I'll show you, this was actually from a couple weeks ago. You see by my nail polish color. That's me handing over some samples of worm bodies and heads. And then just recently, I love this obligatory Caltech scientist Red Bull in the picture. We were able to make crystals from our worm samples. So for Christmas this year, we will be seeing what's coming out of these crystals. And for me, that's the carrot out at the end of the stick, because more worms can help more people. Truly, that's our goal. And before I wrap, I'll say this is the last chapter of my talk, and the shortest. Don't worry, it's almost over. I'm sure some of you have thought, but why? Why do worms make medicine, right? And it could be partially due to the fact that for some reason, areas of the world that still have gut roundworms are spared from these inflammatory diseases. Far less type 1 diabetes, rheumatoid arthritis, multiple sclerosis, inflammatory bowel disease. There's something about these gut roundworms that are protective. Could it be because we actually have had them for a long time? They are our old friends. They've been with humans for millions of years as human ancestors have evolved, making this medicine to benefit their host. And is it a coincidence that when we abruptly remove them because we thought they were so gross, that suddenly there was a historic surge in all of these diseases? Well, I can't answer that question, but I invite you to consider that possibility. And so, when you now look at this world, I want you to think about the bright future ahead, all of the millions of people enjoying their croissants, you enjoying, walking with your best friend, having a laugh, being able to enjoy beautiful, quiet moments, both on yourself and with your loved ones. And I invite you to join me on this journey of keeping hope alive, helping these people just to not only enjoy their moments, but to live complete lives. Thank you.